As we begin factoring, we're going to first start with looking at the greatest common factor. So if I have a statement as x squared minus 5x, and I'm looking for what they have as the greatest common factor. Both terms have an x, so I could take that out on the outside. That makes x squared into x, and negative 5x into just negative 5. So the greatest common factor in this expression is x. The factored form is x times x minus 5. Now, this is the opposite of doing distributive property. Distributive property, we'd multiply the x to both terms and get back to this. So keep that in mind as we go through. Greatest common factor is really just the opposite of distributive property. So in the next one, I have 9x to the third and 36x squared. If I'm looking at coefficients, 9 and 36, 9 is the greatest factor, common factor between the two. X to the third and x squared, they at least have two x's. So I'm going to take out an x squared. This leaves me with an x on the first term. The second term divided by 9x squared leaves me with a 4. So 9x squared, x plus 4. Now when we have three terms, we have to make sure all three of them have it in common. So they all have a 7, 28, 35, and 14. They all have at least one x, x to the fourth, x and x squared. And they all have at least two y's. So the greatest common factor is 7xy squared. That leaves you with 4 x to the third y in the first one. Took out 1x, leaves me with 4. Took out 2 y's, leaves me with 1. Next one, 35, I'm going to take out 35 divided by 7 is 5. X comes out. Y to the third, we took out 2 of them, so we're left with 1 there. Then we have 14, it became a negative 2, and then 1x left over. So that's factoring by its greatest common factor. Now the other thing we're going to look at here, and they're not really related, but we're going to work together with them, is difference of squares. So whenever I have a square minus a square, let's go back and look at that multiplying I did in the previous section. So I would have said that x squared minus y squared would have been my end result. And if that's the case, I would have had x squared in this box and negative y squared in that box. Now the terms that were the common terms, which I don't really have here, didn't show up, but let's kind of see what we can get. So if I had x squared here, I would have an x and an x. And negative y squared, I'd probably have a negative y and a y. In doing that, this box would be xy. This one would be negative xy, which actually makes it to 0, and we got that result. So kind of like working in a puzzle and undoing it, I found that my factors are x minus y and x plus y, which is the factors for the difference of squares. Now what if I did x squared minus 1? So negative 1, bottom right corner, x squared, top left corner. I would have had x and x. Now for negative 1, positive 1, these boxes would have been x and negative x, which is again a 0. So my factors here are x plus 1 and x minus 1. And what we start to notice in this pattern, like it says, it's the difference of squares. When I have a square minus a square minus a square, because square root of 1 is 1, it comes out to be the square root of them in two separate binomials, one with addition and one with subtraction. So let's look at the next one and kind of guess where it'd go. Well, the square root of x squared is x, and the square root of 49 is 7. So this is going to be x minus 7, x plus 7. If we kept it going, 49x squared minus 1, the square root of 49x squared is 7x. The square root of 1 is 1, so I'm going to go 7x minus 1, 7x plus 1. So now we take this idea of difference of squares and greatest common factor and start to put them together. So 3x squared minus 48. First step, we look for a GCF. Once we get that, we're going to look at difference of squares. Now later on, we'll have other methods to factor with, but I would always look for the GCF first. So looking at this one, I can't do difference of squares here because they're not perfect squares, but they do have a common factor. I can take out a 3, and that leaves me with x squared minus 16. Now from here, that's a perfect square, that's a perfect square, so that's going to be 3x minus 4, x plus 4. Okay, if I come over here and look at x to the fourth minus 16, consider this a bonus one, not one I skipped in class. So x to the fourth minus 16. This is a perfect square, and this is a perfect square. This is x squared squared. So that's x squared, x squared. So we're going to go minus 4 plus 4. Well, that is not difference of squares, but this is. So I can actually keep going with this one. X squared and 4 become x minus 2, x plus 2, with x squared plus 4 there. So I could actually repeat that process and do difference of squares multiple times. And in some cases, that would work. Now, come down to our last one on this page. Again, I'm going to look GCF first, then difference of squares. If I look at it first, 49 and 25 are perfect squares. The issue is the variables don't work. Now, they both have an x and y in common. So if I take that out, it's now 49x squared minus 25y squared. The square root of 49x squared is 7x. The square root of 25y squared is 5y. Make one addition, make one subtraction, bring down xy, and there is my factored form of the polynomial. Now we keep going. I have x squared minus 4x. Now, although this is a perfect square and 4 is a perfect square, the x messes things up. So this is not a difference of squares problem. I'm going to take an x out, and I'm left with x minus 4. Now, even though this is a perfect square, this is not. So I'm not going to simplify that. That is the factored form of that. Next, I have 8d to the third plus 28d squared. I'm going to take out a 4d squared. 8 divides by 4, and 28 divides by 4. So this leaves me with 2d plus 7. Next row, I have negative 18q to the third and negative 6q squared. Let's imagine I look at this one and I say, hey, they both are divisible by 3. And I go 3q squared. So if I did that, I'd have negative 6q minus 2. Now, I didn't get the greatest common factor here. It worked, but I still have a 6 and 2 left in there, which have a greatest common factor of 2. So what I'm going to do is now take out a 2 also and multiply that to the 3. And it's now 6q squared minus 3q minus 2. So, oh, not minus 2, minus 1. So from there, that was actually the greatest common factor, 6q. So even though I only did 3q squared first, I noticed there's still something left. I could keep going. The last thing I would add to that is normally whenever we factor, we want that lead term to be positive because it allows for factoring that we're going to do later to be a little bit easier. So I'm just going to take out a negative 1, make it negative 6q squared on the outside. So that just becomes 3q plus 1. And over on our next one, I look at all of these numbers, 20, 80, and 35. 5 is one they all have in common. They all have at least 2 m's, and they all have at least 2 n's. So that's my greatest common factor. I'm left with 4 m's are gone, 2 n's. Then 16 is 80 divided by 5, 1 m and 1 n each. And then a minus 35 is going to give me 7. M is gone, N is gone, it's just going to be a minus 7 by itself. 5c squared minus 125. Now 125 we hopefully know is 5 to the third, but we need to look at GCF first. If I take out a 5, I'm left with c squared minus 25. That's a perfect square, that's a perfect square. So we're going to make that c minus 5, c plus 5, but don't forget to bring the 5 down. The last one I have here, I'm actually missing something. I'm going to put it in x, y to the third. That's what I intended to write when I put it there. So we're looking at that. They both have an x and a y there. So if I took that out, I have 36x squared minus 64y squared. And looking at that, both of those are perfect squares, but they're not factored all the way. So I'm actually going to divide a 4 out of both of them. So that's 4xy. Now it's 9x squared minus 16y squared. Still perfect squares, and now this is going to factor to be 4xy, 3x minus 4y, 3x plus 4y. If I didn't take out the 4 here, I would have had 6 and 8, which meant I would have had to factor both of these twice, which gets me the 4. And that's the benefit of factoring the GCF from the beginning before waiting until the end.